Hello friends, welcome to my YouTube channel VKS Chem Tutorial. In this video, I will discuss Barton reaction, otherwise called Barton nitrite ester reaction. It is a photochemical reaction that involves photolysis of an alkyl nitrite to form a delta nitroso alcohol. This reaction involves photolytic decomposition of an organic nitrites to alkoxy radical followed by regioselective intramolecular hydrogen abstraction by the alkoxy radical and recombination of the resulting carbon radicals with nitric oxide radical produced to form nitroso alcohol. Okay, see this alcohol, it contains delta hydrogen atoms. It is alpha, beta, gamma, delta. There are two delta hydrogen atoms. And when an alcohol with delta hydrogen atom is treated with nitrosyl chloride, corresponding alkyl nitrite or nitrite ester is first formed. Then this nitrite ester or alkyl nitrite, upon photolysis in presence of benzene and nitrogen, forming delta nitroso alcohol. Delta nitroso alcohol. This position is delta position. Here is a nitroso group and hence it is called delta nitroso alcohol, which tautomerizes to produce corresponding oxime, that is oxymino alcohol. The oxime on hydrolysis, we will get delta keto alcohol, that is alpha, beta, gamma and delta. Delta keto alcohol. It is the corresponding alcohol of this oxymino alcohol when it is hydrolyzed. Then when oxymino alcohol is reduced with lithium aluminum hydride, we will get corresponding amino alcohol, that is delta amino alcohol is produced. Okay, see the mechanism of Barton reaction. First of all, homolysis of nitrite ester on photoirradiation gives alkoxy radical, this alkoxy radical and nitric oxide radical. That is, homolysis of alkyl nitrite or this nitrite ester takes place on photoirradiation. Homolysis of this bond, this oxygen-nitrogen bond takes place by photoirradiation, forming this alkoxide radical and nitric oxide radical. And the next step, intramolecular hydrogen abstraction by this alkoxide radical at the delta carbon atom, that is regioselective abstraction via a six-membered cyclic transition state take place, and the generation of a delta carbon radical. That is, here this alkoxide radical abstract delta hydrogen atom from this carbon atom, that is hydrogen atom at the delta carbon atom. Intramolecular hydrogen abstraction from this delta carbon atom takes place via a six-membered cyclic transition state, thereby forming a delta carbon radical like this. And in the next step, recombination of carbon radical and the nitric oxide radical formed earlier to form nitroso alcohol. See, this carbon radical, delta carbon radical, reacts with or recombined with the nitric oxide radical, forming the product nitroso alcohol. It is nitroso alcohol, which tautomerizes to produce an oxime. It is the oxime produced by the Barton reaction. The nitroso alcohol formed gets tautomerized, forming this product oxime, hydroxyoxime. Okay, that is the mechanism of Barton nitrite ester reaction or Barton reaction. This is an example of application of Barton's reaction in steroids. This steroid molecule, on treating with the nitrosyl chloride, corresponding nitrite ester is formed, which on treating, which on irradiation or on photolysis, see this molecule containing delta carbon atom with hydrogen. So Barton reaction takes place forming nitroso alcohol. Delta nitroso alcohol is produced, which tautomerizes to produce corresponding oxime. This oxime upon hydrolysis forming corresponding aldehyde. We can convert this molecule into an aldehyde by Barton's reaction. It is an application of Barton's reaction in steroids. Okay, I have already discussed the Barton's reaction, its mechanism with an important example. I hereby conclude this video. Thank you so much for watching. Thank you.